Hi, I want to take you today through assignment 7, which is going to be linear perspective. Now, some of you may have already had some of this before, but hopefully there'll be a few new insights for you. I want to look at some slides, and this is the same slideshow that you'll get online. Um, the assignment demo is built into this slideshow, so that should be very helpful when you go to do the assignment. So we're looking at linear perspective, which is a spatial device. And here's an example of two-point perspective. So this is a little more complex than single-point perspective that you'll do on your assignment. But perspective teaches how to draw objects in order to create the appearance of volumetric space. So this is how when we see things in the foreground and then we see things in the background, they look correct. They look right with each other, and we can see this implied volume in this space. This two-dimensional surface looks three-dimensional. So hopefully this will demystify pictorial space for you. We can see how to create naturalistic volumetric objects, and it should be a valuable resource when you're creating drawings and designs, and especially for planning out designs for real spaces. It's objective, which is a cool thing about perspective, is it's either right or wrong. So there's nothing subjective about whether you've got the perspective right or wrong. It is probably the most important technical development of the Renaissance. They figured out how the geometric and measurable mapping of space would work to make this nearly scientific. In general, art of previous eras appeared flat or unrealistic, and we saw that when we were looking at space and shape before, how there was a lot of overlapping, but there wasn't true linear perspective that would show us deep, deep space. Here's just an image. So you can read through all of this when you go through the slides, but the relative points I want you to know are point of view, and that's just where you're standing and where your cone of vision is coming out from your eyeballs. The picture plane is this flat imaginary window through which we're looking when we're looking at a painting or a drawing. The horizon line is simply where the sky meets the earth. And below the horizon line, we can call the ground plane. And above it, we can call the sky plane. An eye level, that's pretty obvious. Now, vanishing point. Vanishing point is the point at which all lines converge. And the reason there's a vanishing point is because our binocular vision can only focus on one thing at a time. Sure, we've got peripheral vision, but we can only focus in on one thing at a time. And that's what makes linear perspective work. Convergence and converging lines, that's like when you look down railroad tracks. If you were to draw railroad tracks and just draw two parallel lines like this, and then the ties across, it would just look like a ladder. But if you draw it instead with the lines converging, it looks like there's distance and the tracks are going off into the depth of the scene. Foreshortening, we know what this is. When there's something close to us, it looks big. When something far away, it looks small. So we'll be doing single point for our assignment. And that just means that the viewer is only looking into the scene from one direction. If we have two-point perspective, that means that it's implied that we could look one way into the scene, and we could also look and turn our heads and look at a different direction in the scene. Three-point goes further and this would be like if you're looking up at a tall building from the corner. So you can see down the street in one way, you could turn your head down the other way, or you can look up and you'll see up to the top of the building. So we've got convergence happening in all directions. The top of the building would work converging up to a zenith, which is a high point, and the sides would happen in two different points. Orthogonal lines are just guidelines that you use to draw in where you need to make things happen. So we'll see that things get smaller as they recede, objects appear larger as they're close to us. All level, horizontal, parallel lines that are above the horizon line will shrink as they recede in the distance. This will make more sense when we look at the example. Vertical lines are always parallel to the sides of the picture plane in one-point perspective. Horizontal lines are the ones that will go inward. And that's when you're looking at sides of objects. So here's where it steps through the sort of drawing that you're going to do. And here it is divided. Here I've got a horizon line across the middle of the page. I've got the sky plane above it. I've got the ground plane below it. And then I've got a vanishing point in the center. Look how terrible I was with this Microsoft Word drawing, or picture of a pencil drawing is what this is. I didn't get this quite centered. But this is called a central vanishing point, the CVP. From this, I want you to draw a rectangle around the central vanishing point with equal sides. So everything is centered up like this. What we're going to build the interior of a room. So you can think of this like us being inside of a box. To get the walls of the room and the ceiling and the floor and the other wall, what we do is we put our pencil down with a straight edge and we connect that dot with this corner. Not the corner of the page, not the corner of the page, this corner. So you draw, so these are orthogonals, and then here we go solid line. You draw straight out from there. Same thing happens over here, from the center point to this corner, and then straight out from there. Same thing happening down lower. Then we could erase that horizon line. We don't need it anymore. And you can see here that that illusion of being inside of a room is created. Now, if we're going to build a window, we need to first put in a line. So we put in a line however large or long we want to make it tall. Then we go from that vanishing point right up to where that line ends. And then we can extend that as far as we want, and we can build this window. We do the same thing for the bottom, vanishing point to the bottom of that line segment, and then we draw it out like this, and then we can connect these two. We could do the same thing if we're going to put in window planes. Now, this door is on the back wall. So, because of that, it does not show any perspective. It's just flat on. So it's straight in front of us. It's not on the wall or anything like that. It's just flat on. So it's just a door and it's slapped on that rear wall. When we get a little more complex, we want to build something like a couch or a chair. What you do is you build rectangles. So we've got one rectangle here that we've built. We've got another rectangle stacked right up on top of it. Then its central vanishing point orthogonals down to here, or you can connect here, and then pull that back, and we get this converging line that's happening. And then we can do the same thing from this point, pull it back, and we see where this segment needs to happen. We go straight over with the top of this arm because these are staying straight. They're straight horizontal. And then we can go from this point, pull back. That's how we get this end of the line. Then we go from this point and pull back, and that's how we get this corner. And we go from the end of the line segment over here up to here, and that's how we get where this point happens. Now, obviously, we could do this in reverse. You could draw this shape first, and then go orthogonal through to the bottom of that shape, pull that over to here to get where this corner should happen. So it operates the same way as the window, but now we're getting 3 dimensions built into the couch. And so you see that when we erase the orthogonals and we erase this bit of the floor to ceiling, the floor to wall line, we can't see that behind the object, so that's been erased. And now we've built this really uncomfortable couch. We can put ductwork into the room. So cylinders are pretty straightforward. And what you do is you put a circle in, like up here, and you go to the part of the circle that would be visible when we're looking up at the top. And we come down here to the vanishing point, and you can see how this all connects up. So you can do this circle first or this circle first. This may be easier to do this circle first. Use your compass, make a circle on that rear wall, and then use the vanishing point connected to this point on the circle and pull that out up here. Same thing down here, we pull that up here, and then we'll fit the largest circle that we can within those lines. And we'll do the same thing then. We'll erase out everything we can't see when looking at this duct or this tube, this cylinder up on the ceiling. Now, it gets more complex doing something like a table. And the way to do this is to build a cube first. So very lightly build out a cube like this. Then what you do is you bisect that cube, quarter it. So I've got these cross lines happening across the top. So just like the window panes, except now we're horizontal. And then you've got to tell yourself, okay, for the top of this tabletop, it has to skew and agree with these converging lines and where it's sitting off center, so our eyes are looking over to here. And logically, we know that within this quarter of this cube, this has to make a full arc from halfway to halfway. And that's what will guide you in sketching in how this arc has to happen. So we could figure this out geometrically, but I don't really know how. So you're going to sketch this in as best you can. So the arc has to come all the way around and hit right at that corner. So each corner. So you can see the arc for this section is a lot different for the arc for this section. Then what we can do is we can add a little depth right there. We can copy the arc right below, and then when that will establish our tabletop. From these quartering lines, we can also put in legs, and those are just straight lines down at each of the quartering sections. You can see this bit of arc here covers up where this leg is because this point on the quarter point would come straight down, so we can't see it through the table, and then down below it we can see it. Erase everything we don't need, and here we go. So the legs reinforce that this is a table and we've got a coffee table down. So here we've got everything. This is a super basic room, and from the knowledge that you've got here, you can build all kinds of things. And there's a list of things I want you to build in the assignment instructions. You know how to build circles that are working within perspective, cylinders, flat objects, and dimensional objects, and then flat objects that are in perspective. Probably the hardest challenge, and this is not a requirement, but a suggestion, is to try to build a ceiling fan. You would take the same ideas that you used here and put it up here on the ceiling and try to figure out how the fan blades would have to work to make a convincing ceiling fan. So here's a few examples of other work that's showing perspective. This is obviously not inside the cube like an interior, but outside of cubes and other shapes. And you can look through these and you can see how that central vanishing point is using convergence to make these shapes look volumetric. So here's a cool interior. And look how extensive this is. Um, this is really built up. You can see, for example, where you've got something like a couch, you would build it first out of cubes and rectangles, and then bring in the rounded edges once you've got all of the perspective figured out. Here's some interesting complex shapes that have been cut out of this overall rectangle. These stair steps happening, going through everywhere. And then this is a paw-shaped window so we can see this tree outside. Really cool drawing. It's a great opportunity for any of you going into interior design to learn how to build a room. Very important. It's an exterior two-point perspective shot. So this is what I mean. You can see on this one, the horizontal lines converge at a point over here, and then over here they converge at this point. So again, you are only required to do a single point perspective room. If you know how to do a two-point perspective room, go for it. It's a bigger challenge and makes even more interesting interior scenes. Another exterior two-point. This one's great with all the shading. Really well done, really convincing. Abstract architecture. So check this out. This is all in single point perspective. Really interesting where the vanishing point is, isn't it? Where the most important character for this scene is sitting. Here we go. 2-point perspective, 3-point perspective used in cartoons. Okay, so read the assignment instructions, write to me if you have any questions.